In this lesson, we're going to be looking at solving for angles in which your angle in standard position, theta, will be between 0 and 360 degrees. We know how to solve for theta when theta is acute. Using SOHCAHTOA, we would type in theta equals cos inverse of 7/10, and that would give us our angle. But in this case, since theta is now between 0 and 360, we know there are two places in which our theta in standard position can be, because cos is adjacent as compared to hypotenuse. And there are two places that it can be positive. Quadrant 1, our adjacent could be 7 and our hypotenuse could be 10, or in quadrant 4, our adjacent could be 7 and our hypotenuse could be 10. You get a positive over a positive or a positive over a positive. There are two possible places for theta. Theta could be acute, or theta could be between 270 and 360. So how do we find that other angle? Well, we just plug in what theta would be in standard position in quadrant 1 and calculate that. So when I calculate cos inverse of 0.7, I get approximately 46 degrees, which I can call my reference angle, what it would be in quadrant 1, and then I just apply that reference angle to the correct quadrant in which cos is also positive. So my reference angle would also fall there. So my two angles, my first angle is the same as my reference angle, which is 46 degrees, and my second possible angle for theta in standard position would be 360 subtract my 46, which becomes 314 degrees. So we are getting two possible angles in standard position when theta is between 0 and 360. So in general, to find the theta, we find the reference angle using the positive ratio. We have to use the positive ratio because that would give us the angle of what it would be in quadrant 1. Then once we have our reference angle, we use our cast, or the sign of the ratio, to determine the two possible quadrants for the reference angle. And then you place that in the two possible quadrants and you calculate your two angles in standard position. Let's try another example. Sine theta is negative 0.906. Well, to calculate our reference angle, we take the sine inverse of the positive ratio. So we go 0.906. So we type that into our calculator. Oops. And I get that my reference angle is 65 degrees, rounded to the nearest degree. So where is sine negative? Well, sine is always y over r, and r is always positive. Where is y going to be negative? Y is going to be negative in quadrants 3 or quadrants 4. That's where y is negative. Or in other words, sine is negative where y is negative. Quadrants 3 or quadrants 4. Or you can use the cast rule. Okay, the cast rule just tells you where the ratios are positive. Only sine is positive there and sine is positive there because all of them are positive. Therefore, sine has to be negative there. However you memorize it, it's fine with me. So now you plug in your 65 degrees for your reference angle. It could be there or it could be there. So your angles in standard position are going to be, there's theta 1, which is going to be 270 plus 65, which is 335 degrees. Whoops, why did I say 270? 180 plus 65, which is going to be 245 degrees. Or it's going to be 360 minus 65, which is 295 degrees. So those are your two possible angles for theta in standard position. Let's try another one. If tan theta is negative 1.19, then the reference angle is going to be tan inverse of 1.19. So I go shift tan 1.19 I get 50 degrees approximately. That is my reference angle. And where is tan negative? Well, tan is going to be opposite over adjacent. And where they're both, where y is negative and x is positive, would be one possibility. Or when y is positive and x is negative would be the other possibility. So my two reference angles would be, my two angles in standard position, theta is going to be either 180 subtract my 50, or it is going to be 360 subtract my 50. And those are two angles in standard position, from 0 to 360 for theta. A little note, you should be able to recognize ratios that are exact values. So if you can also work with your exact values, you don't need your calculator, you should be able to recognize when a ratio is giving you an angle that is your 30, your 45, your 60, your 90, 180, etc. Exact value style ratios. So 0.5, remember our special triangle, our 30, 60, 90, where this is 1, 2, root 3. Where are we getting 0.5? Cos 60, adjacent over hypotenuse. Cos 60 gives you 1/2, so you should recognize really quickly that the reference angle is 60 degrees. So once you know the reference angle, you now just put the reference angle in the appropriate quadrants. Cos is positive, since this ratio is positive, cos is positive there, and cos is positive there. So your two angles in standard position are 60 degrees and 130 degree, right? 60 degrees and 130 degrees. Sorry, 120 degrees. 120 degrees. Again, 1 over root 2, we should quickly recognize that theta is 40 degrees. Sorry, 45 degrees, having trouble with my numbers today. 45 degrees, because that is my 1, 1, root 2 triangle for a 45 degree angle. And therefore, where do I put 45 degrees? Well, sine is positive, and sine is positive in that quadrant and that quadrant. And so we have our two angles to be 45 degrees, or 180 minus 45, which is 135. Negative 1 over 3. Okay, how do I memorize that one? I usually memorize this one. When 1's on the top, we know that 1 is always across from the 30 in my special triangle. So 1 over root 3 is my 30 degree. Root 3 over 1 is my 60 degrees. So I can recognize when the 1's on top that theta is 30 degrees, or my reference angle is 30 degrees. So where is tan negative? Tan is negative in this quadrant, quadrant 2, and this quadrant. Remember, always make your reference angle with the x-axis. Never make your reference angle with the y-axis. It's always made with the x-axis. So your two angles are going to be 180 subtract the 30, which is 150 degrees, or 360 subtract the 30, which is 330 degrees. Working with your special triangles, you should be able, in exact values, you should be able to come up with that reference angle pretty quickly. Just remember, ignore the negative when you're finding that reference angle. What happens if sine is 0? Well, where is 0 for sine? Well, 0 is one of your quadrantal angles, your 90, 180, etc. And sine theta in your unit circle is always going to be y as compared to r. Or if r is 1, it's just going to be y. So in other words, where does y equals 0 as it goes around? Well, I can just list my points as it goes around. This is 1, comma 0, this is 0, comma 1, this is negative 1, comma 0, and this is 0, comma negative 1. So where does y equal 0? Y equals 0 there, and y equals 0 there. So there's two places, two values of theta where you're going to get a 0 ratio. And so those two values of theta are going to be at 0 degrees, at 180 degrees. Oh, and actually there's another one, because if you look carefully it says less than or equal to 360. When you get around to 360 degrees, again, you have that ratio. You really have to look at your domain for your answer to know where your interval is, right? So if I change that domain to being, whoops, get rid of that equal sign, to being this, how would my answer change? Theta has to be between, but not equal to 0 and 360. Then I would have had to get rid of those two answers and only 180 would be the answer. So you have to look and see if your ends of your intervals are included in the interval. Let's try another one. Cos theta equals 1. Where does cos theta equals 1? Remember, in your unit circle, cos theta is just x. It is the x coordinate as it rotates around your unit circle. Sine theta is your y coordinate as it rotates around the unit circle. So where does x equal 1? Where does x equal 1? X equals 1 right there. It does not equal 1 there. It equals -1 there. And it equals 0 there. So there's only one place in where x is 1. So in this case, theta is equal to 0 or 360 degrees. If I had gotten rid of those equal to signs, then there would be no solution, right? There'd be no value of theta that falls where x is 1 within that interval. Okay, so making sure we really make sure we match that up. And that is how you find the angle. So sometimes you have 1 angle, sometimes you have 2, sometimes you have 3. The only time you'd have 1 or 3 is if you're dealing with a quadrantal angle. If you're ever dealing with an angle that is not quadrantal, you will be getting 2 possible angles for theta in standard position given a ratio.